Sponza class demo. At the moment we're looking at the GroupedObj file, and as I said previously, it inherits from the NGL abstract mesh. You can see I've got a couple of default constructors. I've got a load method, save method, save binary, load binary. Because I've got most of the information being stored in a std vector of mesh data, I decided to open up that vector to outside the class so that we can easily iterate through and do what we wish to. This makes it easier for other people to extend and access things within the class without obviously making it private. So I'm going to return a std vector mesh data const iterator begin and end, and also the non-const versions of the same thing. So you can see those there. I've got some debug printing data. The main draw method, which will take in the ID of a mesh, which we can find out how many items there are from num meshes below there, the accessor. And then I've got methods to get the material, get the name. So material is the name of the current active material for the element at that index. Name is the name of the group at that index. Then we've got all of these parse functions. Now, the OBJ is actually quite a complex structure, and it can have more than one different way of storing the data. Now, there is one case which I'm not going to deal with, which are the use of negative indices, because that makes it a lot more complex to write a parser. But it is possible to actually have negative face indices, which are basically relative to previous ones. However, in this case, what I'm going to do is I'm going to use the Boost Spirit parsing library to do most of the hard work for me. And a lot of this code was actually originally in a brilliant open source project called the Cortex API, which is a Cortex VFX project. And you can find that on Google Code. So I basically looked at their code and re-implemented elements of it, and I've cited that in the code, as you can see as we go along. So first thing, we're going to concatenate the namespace of Boost Spirit into SPT, so saves running Boost Spirit all the time, and we're just going to specify our grammar, which is a spirit rule for a spirit's phase scanner type, and we're going to call that S rule. Now that makes it a lot easier to write the code, and it makes it slightly less verbose, but we're still not just importing the namespace wholesale, which is against our coding standards. So here's a typical sort of parse function. What that will be passed in is this constant character pointer, called begin in this case, and the parsing rule will look something like this. Here we have our phrase scanner rule. I've called it vertex, and it's made up of a v followed by a real value, another real value, and another real value. So if it doesn't satisfy these rules, the parser will put errors in. And as it's parsing, it appends the data from values into this std vector here. Then, when we want to parse, we just go through, and we call the spirit parse function. We pass in the data to be parsed, our parsing rule, and the separator, which in this case is just a space. I'm not using the result here, so I just pass it to q-unused, so it gets rid of compiler warnings. And then I go through. If it's successfully parsed, we have correct values, so we don't need to check, and I just add that to my vertex list there. And it's pretty much the same for other elements, slightly different for string-based elements. So here's a material element. So the material element is a std string, and I'm looking for use material as the key for the grouping element. Then I'm going to lex, use the lexMeSpirit function, and it's going to be any character followed by, optionally, any other character, and as we get those characters in, we append it to the material. So this is more or less a BNF that's being described here. It's using sort of BNF style rules. And again, we pass it to the parser. If there was anything after it, we just add default. Otherwise, and this is the key to how we're going to go through this, basically we copy material into our current material. This is the material that we're dealing with. This is what all of the other entries will be associated with as we parse through. And we just use trim to get rid of any white space either side or any other odd characters. Parsing the group. The group is defined so that first time round we need to, we set this first time. Obviously we get the group, we don't trigger the end of the group until we get the next group. So first time round we basically don't add the current group back, we just store it. Next time through, this static one will store all of the previous parsed values that we've got and just basically print out some information, and this will store it into our meshes vector, so our array of meshes. And once this is done, I increment my offset, which is going to be used in consecutive runs through to determine which is the next offset for the element to be drawn, and so on. But face count we reset to 0 because that's the number of faces we need to draw each time we draw one of the little groups. And again, there's some more parsing elements there. G begins with a group, we're just splitting it for the current values, and so on. Texture coordinates, normals, are more or less the same sort of thing. Faces are slightly more complex, and I will show you the rules here. An entry for a face can be at least one integer value, which is an index, with optional values of another integer or nothing, and a slash again, and another integer or nothing. And finally, this is repeated multiple times. So again, here's our first rule. Then we make the rule for the actual face. So a face is made up of at least an entry, another entry, another entry, then optionally there can be more entries. So basically this parser will just cope with all of the rules, and you can see that this is actually quite a nice way of specifying these things, because it could get quite complex having to do this ourselves. So Boost Spirit definitely saves us a lot there. Once we've got this information and we've parsed it, we can go through and see. So first thing I deal with is if the number of vertices are not equal to 3 but are equal to 4, that means that we've got a quad rather than a triangle. If we've got a quad, we can quite easily convert that into 2 triangles while still preserving the normal and the UV information. Any other case I can't really deal with, because we'd have to actually go through and recalculate lots of other things. So I decided to just not bother. That can be done in Maya so much easily, or any other animation package. So split face I'll come back and show you later, but it's more or less the same as this. We go through, we loop for each of the vertices, and we push back our face indices, which are in an OBJ, they start at 1. Obviously ours start at 0, so they need to be changed for that. Then we see optionally if we've got normals and UVs, and we add them back through. And then we increment our face count by 3, because each time we're going through a different amount of faces. And then finally, the split face, you can see it does the same thing. I'm making several assumptions of the face structure, which is a counterclockwise winding. So face 1 is going to be the index 0, 1, 2, and face 2 is going to be index 0, 2, 3. I just go through, push those back into the respective faces, and do the same if I have the normals and the UVs. And then finally, I'm just pushing back both of the faces and adding 6 to the count. So that's the majority of the parser done. The final element of the parser can be seen here in the load function. I'm just going to the load function. So basically we need to build up a few more rules for other elements which are in the OBJ. So a comment is a hash. We'll tell it to ignore those. Then we make up our rules. A vertex V is a spirit real, 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 and then we bind it to the parse vertex function. Same for VT, VN, use material and group. So we basically, what this is doing is it's binding our rules to a function so that these functions can be used anytime these things are encountered. And then we gradually build up vertex type, face, and so on, and the overall parse is here. Read in a line at a time. We convert that to a C string and we parse it based on one of those elements that are there. And that's it. That's why Boost is quite powerful for this sort of parsing. It's very good. It's quite small code. It's more or less following a BNF, so it makes our life quite easily.